Hey guys, this is Chemical Applications of Group Theory by F. Albert Cotton. Preface. The aim, philosophy, and methodology of this edition are the same as they were in earlier editions, and much of the content remains the same. However, there are changes and additions to warrant the publication of a new edition. The most obvious change is the addition of Chapter 11, which deals with the symmetry properties of extended arrays, that is, crystals. My approach may not, or it may, please crystallographic purists. I did not have them in mind as I wrote it. I had in mind several generations of students I have taught to use crystallography as a chemist's tool. I have tried to focus on some of the bedrock fundamentals that I have so often noticed are not understood, even by students who have learned to, quote-unquote, do a crystal structure. Several of the chapters in Part 1 have been reworked in places, and new exercises and illustrations added. I have tried especially to make projection operators seem a bit more, quote-unquote, user-friendly. In Part 2, besides adding Chapter 11, I have considerably changed Chapter 8 to place more emphasis on LCAO molecular orbitals and somewhat less on hybridization. A section on the basis for electron counting rules for clusters has also been added. Finally, in response to the entreaties of many users, I have written an answer book for all of the exercises. This actually gives not only the bottom line in each case, but an explanation of how to get these in many cases. The answer book will be available from the author at a nominal cost. Preface to the second edition. In the 7 years since the first edition of Chemical Applications of Group Theory was written, I have continued to teach a course along the lines of this book every other year. Steady evolutionary change in the course finally led to a situation where the book and the course itself were no longer as closely related as they should be. I have, therefore, revised and augmented the book. The new book has not lost the character or flavor of the old one, at least, I hope not. It aims to teach the use of symmetry arguments to the typical experimental chemist in a way that he will find meaningful and useful. At the same time, I have tried to avoid that excessive and unnecessary superficiality and unfortunate consequence of a misguided desire, evident in many books and articles on theory for the chemist, to shelter the poor chemist from the rigors of mathematics, which only leads, in the end, to incompetence and its attendant frustrations. Too brief or too superficial a tuition in the use of symmetry arguments is a waste of whatever time is devoted to it. I think that the subject needs and merits a student's attention for the equivalent of a one-semester course. The student who masters this book will know what he is doing, why he is doing it, and how to do it. The range of subject matter is that which, in my judgment, the great majority of organic, inorganic, and physical chemists are likely to encounter in their daily research activity. This book differs from its ancestor in 3 ways. First, the amount of illustrative and exercise material has been enormously increased. Since the demand for a teaching textbook in this field far exceeds what I had previously anticipated, I have tried now to equip the new edition with the pedagogic paraphernalia appropriate to meet this need. Second, the treatment of certain subjects has been changed, improved, I hope, as a result of my continuing classroom experience. These improvements in presentation are neither extensions in coverage nor rigorizations. They are simply better ways of covering the ground. Such improvements will be found especially in chapters 2 and 3, where the ideas of abstract group theory and the groups of highest symmetry are discussed. Finally, new material and more rigorous methods have been introduced in several places. The major examples are 1. the explicit presentation of projection operators, and 2, an outline of the F and G matrix treatment of molecular vibrations. Although projection operators may seem a trifle forbidding at the outset, their potency and convenience, and the nearly universal relevance of the symmetry-adapted linear combinations, SALCs, of basis functions which they generate, justify the effort of learning about them. The student who does so frees himself forever from the tyranny and uncertainty of intuitive and seat-of-the-pants approaches. A new chapter which develops and illustrates projection operators has therefore been added, and many changes in the subsequent exposition have necessarily been made. Because chemists seem to have become increasingly interested in employing vibration spectra quantitatively, or at least semi-quantitatively, to obtain information on bond strengths, it seemed mandatory to augment the previous treatment of molecular vibrations with a description of the efficient F and G matrix method for conducting vibrational analyses. The fact that the convenient projection operator method for setting up symmetry coordinates has also been introduced makes inclusion of this material particularly feasible and desirable. In view of the enormous impact which symmetry-based rules concerning the stereochemistry of concerted addition and cyclization reactions, Woodward-Hoffman rules, have had in recent years, a detailed introduction to this subject has been added. In conclusion, it is my pleasant duty to thank a new generation of students for their assistance. Many have been those whose questions and criticisms have stimulated me to seek better ways to present the subject. Preface to the first edition. This book is the outgrowth of a one-semester course, which has been taught for several years at the Massachusetts Institute of Technology to seniors and graduate students in chemistry. The treatment of the subject matter is unpretentious, in that I have not hesitated to be mathematically unsophisticated, occasionally unrigorous, or somewhat prolix, where I felt that this really helps to make the subject more meaningful and comprehensible for the average student. By the average student, I mean one who does not aspire to be a theoretician, but who wants to have a feel for the strategy used by theoreticians in treating problems in which symmetry properties are important, and to have a working knowledge of the more common and well-established techniques. I feel that the great power and beauty of symmetry methods, not to mention the prime importance in all fields of chemistry of the results they give, make it very worthwhile for all chemists to be acquainted with the basic principles and main applications of group theoretical methods. Despite the fact that there seems to be a growing desire among chemists at large to acquire this knowledge, it is still true that only a very few, other than professional theoreticians, have done so. The reason is not hard to discover. There is, so far as I know, no book available which is not likely to strike some terror into the hearts of all but those with an innate love of apparently esoteric theory. It seemed to me that ideas of the sort developed in this book would not soon be assimilated by a wide community of chemists until they were presented in as unpretentious and down-to-earth a manner as possible. This is what I have tried to do here. I have attempted to make this the kind of book which, quote-unquote, one could read in bed without a pencil, as my colleague, John Woff, once aptly described another textbook which has found wide favor because of its down-to-earth character. Note, this statement is actually and intentionally not applicable to parts of Chapter 3, where I have made no concessions to the reader who refuses to inspect steric models in conjunction with study of the text. Perhaps the book may also serve as a first introduction for students intending to do theoretical work, giving them some overall perspective before they aim for depth. I am most grateful for help I have received from many quarters in writing this book. Over the years, students in the course have offered much valuable criticism and advice.